Overclocking is another option you have in the configuration settings. And you may have heard of this term before. I just want to define it for you and tell you what the options mean. So overclocking generally refers to increasing the clock frequency of the device beyond the recommended frequency. So basically these processors, these machines, it's called synchronous design. So there are clocks, meaning square waves, as up, down, just 0 volts, 5 volts, 0 volts, 3.3 or something like that, that are driving these chips. And the clock frequency is the rate at which the signal goes high or low. So overclocking is also in this context used to refer to increasing the internal voltage levels. Now, this is a bad use of the term, but it's used this way in Raspberry Pi lingo anyway. I don't like this use of the term overclocking. It means increasing the frequency. Increasing the voltage. That's to increase speed. That you can speed up a transistor by giving it more voltage. That's part of the idea, intuitively. But that's what overclocking is. So one thing to know about overclocking is that there's more than one clock inside a device. So if you look at a Raspberry Pi, there's not just one clock. There's the ARM frequency, which goes to the ARM processor core. There's the SDRAM frequency, which goes to the RAM, right? There are other clocks that are involved here. So it's not just one clock. The problem with clocks is that one issue with clocks is that it's very hard to do clock distribution, to send one clock out to all points on the chip at the same time. Because it's important to do synchronous design that the clock edges, the rising edge of the clock when it goes from 0 to 1, that those rising edges arrive at all the different parts of the chip at the same instant. Okay? But there's speed of light difficulties. You can't just make signals travel at the same speed and reach the destinations all at the same time. So there's a little bit of skew. Because of this, what happens is different regions of the chip have different clocks. So you have multiple clocks in there. So just keep that in mind. When you talk about overclocking, it's not just one clock you're speeding up. You're speeding up several clocks. So impact of overclocking. So the first impact of overclocking, the reason why people do it is to speed up the processing. Because roughly, so more instructions are executed more quickly when you speed up the clock, mostly. Because you get roughly one instruction per clock period, right? So if you increase the frequency of a clock, then you're decreasing the period, right? The time between rising edges is getting smaller and smaller. And if you're doing one instruction every clock period, then you get a lot more instructions done. Right? So that's the reason why people do overclocking, to get instructions done faster. And I say roughly one instruction per clock period because there are reasons why that's not necessarily the case based on stalls, but this is more subtle stuff. Roughly, you're getting one instruction per clock. So a risk of overclocking is that it reduces the time that signals have to travel. So in a synchronous design like our chips, signals have to travel from one storage element to the next storage element within a clock period, right? So say there's like a storage element here, register, it's holding a number. And then there's an adder. You want to add that number to another number, and then you want to get the result and store that in another register over here. So the signal has to travel from here through the adder into another register in one clock period. So if you overclock, increase the clock frequency, you're decreasing the time that the signal has to travel through that adder and arrive at its destination. If you decrease it too much, then the signal will not reach its destination by the time the next rising edge happens, which means that the register that's supposed to have the result of the add, for instance, will not have the result of the add in time. It'll have some old result. And when that happens, the whole machine fails, right? Registers start getting wrong numbers and you get a crash. So that's the risk of overclocking. If you reduce the clock frequency too much, these signals won't have time to get to their destinations before the next clock period, and then something will go wrong and the operating system will just crash on you. So that's the sort of the downside, the main risk that you're pushing with by overclocking. And remember that when they fabricate these chips, often the chips are fabricated to a higher frequency than what they're sold at. So for instance, I'm making up numbers a little bit, but let's take our processor. It's sold at 900 megahertz. So maybe it was designed for 1 gigahertz. But what happened was during testing, they tested at higher and higher speeds, and eventually they said, oh, wait a minute, after 900 megahertz, well, once we get to 1 gigahertz, it crashes, right? So we're going to cut off 10%, bring it down to 900 megahertz, and sell it at that. So they provide a little bit of safety margin because there's this variation in the performance based on temperature and things like this. So that's what the safety margin is. And by overclocking, you're getting rid of that safety margin, which may cause you to fail. Temperature of the device also increases as a result of overclocking because power is consumed every time you do a computation, and you're doing more computations per second, so you're heating up the device. So temperature changes. This generally shortens the device lifetime, but that maybe you don't care about that in the short term. It depends on you. So impact of increasing voltage. So that was overclocking. There's also this overclocking where they talk about increasing the voltage. So what does that do to the chip when you increase the voltage? Well, increased voltage swing. So I say voltage swing because you're increasing this swing between the bottom and the top. So 0 volts is the bottom, and the top maybe is 3.3. Maybe I'm going to change 3.4, 3.5. You're increasing what's called the voltage swing, the difference between the top and the bottom voltage. So it may increase transistor speed because the transistor, if it's getting higher voltage, the transistor can switch more quickly. Okay, so that's why it's done. And you have to do that. So if you overclock, then, like I said, signals may not be able to reach the destination in time. So you have to increase the voltage in order to make them reach the destination in time. Okay. So that's why when you see your overclocking options, some of the higher overclocking options also increase the voltage. But a downside of that is that power consumption increases because, well, not only does it increase from overclocking because you're doing more operations per second, but power, it goes with the square of voltage. So by increasing the voltage, you're significantly increasing the power consumption. Thermal effects may alter timing. So when you increase the power, you change the heating. It gets hotter, right? And the heating can change the timing on certain paths in the circuit in a way that is basically impossible for a regular human to predict. I mean, companies, fabrication designers try to predict it, but it's very hard to predict. So the timing can vary in ways that is hard to predict. And that's why crashes occur, because something happens in the timing that you didn't understand. Thank you.